Okay, I'll get started now. So 2 days ago I told you guys to run this command here. Yum group install genome. So what this will do is it will install the desktop, full desktop mode on your computer. So I ran it through, and then it downloaded about 780 megabytes, and it expanded and installed it on your system, right? Yeah. So I'm going to clear this. And I'm going to give it a quick reboot. We'll see how this one will react. To reboot the system, type init6, INIT 6. Okay, it also go ahead and updates the kernel here. Either you could update it separately, or it does it with the part of a full. Okay, I'm going to go ahead and restart session. So let's see here. And so what you should do is you go ahead and, starting from this point, go ahead and change the settings for uh, Yeah, go ahead and shut it down. INIT 0. It will shut down the system, okay? Go ahead and go into settings, network, and here in the host only adapter, change it to bridged network. Okay, and you may or may not have a drop down here. Select the appropriate one here. Okay, you have your own choice how you're gonna select. But if you are connecting to internet here, there should be an option for wireless or non-wireless. So if you could select the one which is non-wireless, that would be great. And go ahead and disable this. So I'm going to take a picture here. Attached to send set bridge adapter. Okay, uh, and the name select whichever one is non-wireless. Or it says a network connection. Okay, and disable adapter 2. Okay, that should be good enough. Okay, so let's go ahead and move forward here. Okay, I'm going to power this up. It will give you a different IP address here, okay? So we'll take a look. So the IP address has changed here, 192.168.56.100. Okay. Yeah. Oh, okay. It didn't change, but let me see if it corrects. 192, 168.56.100, right? Practice. Why I'm not connecting? Okay, I'm gonna quickly give it a reboot here. Okay. Give me 1 second here. Let me check my computer. Oh, bridge adapter. Right. root Red Hat IPADDR. Let me run this command here. System ctl restart. So I'm going to abandon this for a moment here, and I have this a different one. We'll work on this one today. Okay, 236. Okay, so what I'm going to do is I'm going to show you what the levels of reboot, what the run levels are. Okay, I'm going to clear this here, and okay, 05, 25, 20. So I'm going to type in here run level. Okay, so we're going to see what is run level. Run level is the operating system state. So how do you find the run level? You just type run level, and you are in the run level number 3. You could also type who-r, and it says the run level is 3. So in Linux there are about 7 run levels here. I'll tell you which ones are those. Okay, so the very first one, is 0. So run level is 0. Run level 0. Okay, let me. So you have run level. Oh God. So you have run level 1. I'm sorry, run level 2. Run level 0 actually. So this is a shutdown mode. Shutdown mode, and the command you do is init 0. init 0. Okay? And the second run level is run level 1, and this is actually a rescue mode. And it's init 1. And the third one is run level 3. I'm sorry, run level 2. Third one is run level 2. And so the run level 2 is not used. Actually, run level 2 is run level 2 is it has a network connection without NFS, and it's init 2. Okay, run level 4. And not used.
Sir, what is NFS? A network with NFS
Yeah,
that
it's
you
a
wrote?
network file services. You know, sometimes you have a network drive attached to your system. That's what it is. So we'll go into it a little bit deeper. Um, but right now we don't worry about that. It's called network file system. I'll explain you. It's a whole chapter in itself when we're dealing with the network. Okay. All right. So now run level 5 is GUI mode, graphical user interface.
Sir, you for run levels you have 0, 1, 2, and then 3 is missing.
Yeah, 0, 1, 2. Uh, 0, 1, 2, 3 is yeah, 1, 2, 3. This one here, 0, 1, 2,
Yes, sir.
3.
Yes, sir.
Yeah. Okay. Yeah, 3 is the normal one here. Right now we are in the run level 3 here, so this is the one we use all the time here. So 3 is Run level 3 is multi-user mode. Multi-user mode. Okay, and the command is init3, sorry. And this is run level 4, which is not used. Okay, and this is run level 5. This is run level 5, graphical user mode. This is init 5, and run level 6 is reboot, and the command is init 6. These are all lower cases. Okay, so let's go ahead and take a look here. I'm going to type init 6, init 6. So what will happen is the system will start rebooting. It will disconnect and it will start rebooting. So the system is rebooting now. Okay, so I'll go in here, restart, root. Okay, so the system is coming back into, if you type who-r, it will give you run level 3. Run level 3 is multi-user mode, and this is a default mode setup. Okay, so how do you check what mode are you in? Officially you type system ctl get default. Okay, it will tell you are in a multi-user target. Okay, so what I'm going to do is I'm going to type init 5. See, look carefully here. What will happen is the screen will change into the graphical mode. So the graphical mode have to be installed on the system for it to be able to switch to the graphical mode here. Okay, so the system goes into graphical mode, and I could log in here as root Red Hat. Okay, it's kind of goes into familiar um, graphical mode. So you have some applications, you have some information here. So normally you don't use this here, okay? So let me get out of here. I want to get out of this mode. So what I'm going to type is, I'm going to type init3 again. So the system is going to switch back from graphical mode to um, non-graphical mode, okay? Okay, and what do we have next? So number 4 is not used. Number three is run level 3 is multi-user mode, which is default. Okay, this is the default. Okay, and the other two are used for troubleshooting here. So when I type init2 here, I'm sorry, not init 1 and 2 are similar. One is also in a oh, I'm sorry, init 1 and 2 is uh, network okay, yeah. 2 and 3 are similar without NFS. Multi-user. Okay, so 2 and 3 are here, and then number 1 is the rescue mode here. So if I type init1, the system goes into the rescue mode and there is no network. Okay, so the system goes into the some kind of maintenance mode here. And you could do some maintenance here. If I type run level, it will tell you are in run level 1 here. The default is run level 3. So I'm not worried about this here at this point. I'm going to go ahead and go into 3. Oh, you can't go directly from 1 to 3. You have to restart the system. Uh, root. Okay, let me see if I could connect. Okay, so I think it automatically connected. The moment the system came onto the network, it automatically connected. Okay, so how do you set the default run levels? I'm just going to show you the graphical one here. If you want to set it as a default, permanent default here, so what you have to do is, all you have to do is systemctl set default, and then you type graphical multi-user target and graphical target. Yeah. So what you have to do is systemctl, you have to type this here. But before that, let me show you. It updates a file here. It's update the etc configuration file in the system. Okay, let's go ahead and take a look here. Um, so which file is gonna go and update the file here? We'll take a look. etc is gonna go to VIETC default, yeah. Not default. Uh, default. I thought it was default file here. I think, yeah, so the file is system system/default. Okay. Yeah, if you go in this file here, what is this is, you see the description, multi-user system. Okay, so I'm gonna quit this. Um, so what will happen is the following file will be updated. Okay, these files get updated here, right? Um, and in the description will be multi-user mode. So when we're gonna run that command here, we'll come back here and take a look. It will change for you, okay? So the command is systemctl. Okay, set default graphical dot target. So what this will do is, it will edit this file here. It will edit this file. Let me go in there and see. Now you see here the description is graphical interface. Okay. So when is this going to happen? When you run this command here. Okay, so I'm gonna restart the system here. What it's gonna do is, by default, whenever it restart, it comes into run level 3 here, right? But now when I restart it here, it should come into run level 5 here. So let's take a look. Why is it gonna come into run level 5? Because we set it to set it as a default run level. So it's going to go directly into the graphical user interface, GUI. GUI stands for graphical user interface. And the one we normally work is CLI. Can somebody tell me what CLI means?
Command line interface.
Yeah, very good. Who's that?
Fasahat.
Who?
Sir, Fasahat.
Syed?
This is Fasahat, sir.
Oh, Fasad. Okay, so it goes into the graphical mode here, but that doesn't mean anything. You could continue working in the command line mode. So I'm going to type who -r, and it tells us that the run level is 5. Okay, I'm going to go ahead and change this here. Systemctl set default to, what I'm going to set it to multi-user target. I'm going to hit enter. So it's going to edit this file again. It's going to go in there and edit this file. See, it edited the file back to its original one, and then we're going to just reboot the system. So now it shouldn't come into the graphical mode, it should go into the black window. So let me see here. Okay, so it came back into the non-graphical window, So I'm going to restart. Okay, so if I type run level here, who-r, it says run level 3. And if you want to get the default, type system ctl get default and tells you multi-user mode. Multi-user mode is nothing but run level 3. Okay, good. So that is all about run levels. So those things should be clear to you guys. So go ahead, when you've been using here, the one you've been using is init 5, init 6 to restart the system, and init 0 to shut it down. And whatever the default run level is, it will come back into that default run level. Okay, so what I'm gonna do now is let's see, what should I talk about? All right, so let's talk about some a little bit about network and how things work here. So okay, let's talk about what is network. Uh, Network is uh, let's see here. A network is a collection of computers computer server, network devices, and and um, network devices, network devices, peripherals, or any other device connected to one other to allow the sharing of data. Okay, example is internet. Okay, so what is the basic requirement for network? For a network, you have to have a NIC card. NIC card, you have to have a media. Okay, and topology.
So what's a media?
Yeah, hold on. Protocol and IP address. Okay, so for a NIC card, so let's see here, NIC card. Okay, so let's see here. This is an example of NIC card. This is a physical NIC card here, so I'm going to put it in here. Okay, so what this NIC card has is it has a hardware address. It has hardware address, and it has IP address. Okay. Alright, so let's take a look here. What is the hardware address here? So if I type IFCONFIG, we have this NIC card here, and this part is in your NIC card. This part is hardware address, and it is also known as MAC address. What is it known as? MAC address. Okay, so hardware/MAC address. So every devices on the system has a MAC address here. Why? Because this is how the system tracks which component is what here. And this is not a regular information here. It has this is the base 16 information here. So 000, all this, it has a lot of information. It got like the vendor information, vendor code, date information, and all that here. So we're not going to go anything detail in there, okay? And then it has a IP address. You all know this part is a IP address. This is generally what it looks like, IP address 192.168.37, and you may have a different IP address. Okay, and when you say inet6, this is the IP address which is being used here as a version. IP address version, this is a IPv4. It's called IP version 4 address. Okay, and this part is IP version 6. So there are difference between version 5, version 4 and 6, because the world is running out of the IP addresses, which is version 4. So they're trying to use version 6 IP address here. Okay. So if you go on to the website here, what is my IP? So for me, it's gonna show this here because this is my public IP address. Okay, the one the one I put in for the system, this is not shareable on internet, so this is a local. But if you go here on a public IP address, it says this is the public IP address. So far the traditional equipment is using version 4 IP address. Okay, this kind of format you see is similar to this format here, but just numbers are different. Dot dot dot. Okay.
Sir, I also did this. What is my IP on Google, and it is showing me, I think, this version 6 kind of thing, like very long.
Yeah, because
Uh,
you are on a cell phone, right?
no, sir, I'm on a laptop.
On a laptop, it's showing you something like this.
Yes, sir, let me send you the screen grab.
Okay.
I've sent you on the chat.
Okay, and it's giving you the version 6 here, right? Okay, so your internet, how are you connected? Are you using
Sir, Spectrum Internet.
so does it have a cable modem or is just the hotspot?
Uh, it's a wireless network right now that I'm connected with.
A wireless network, you mean it's a hotspot or a Wi-Fi?
Wi-Fi.
And then Wi-Fi, is that a portable box?
So that I don't know. It's just two boxes that are just lying on the table.
How big are they?
So one is as a taller one, and I think that's a router or something. And the other one is a bit small but larger in width, like kind of a box.
Okay, okay. Okay, so your Spectrum is using IPv version 6. Okay, so we may
Okay.
have already ran out of the IP versions here. So the difference is uh, IP version 6 is almost limitless, and version 4 there is a limit here. I'm going to talk about that a little later. How much is the limit there? Okay, so right now you just have to worry about the format, what it looks like. Okay, so the next one is media. Okay, so I'm going to type in media here. Okay, in media, it's just silly things, cables, RJ45. You all know RJ45 cables, right? The Ethernet cable. the cable that goes and plugs into this socket here on the back of the computer, physical computer. It's called RJ45. Uh, it says Cat 5 or Cat 6 cables. Okay, and then Wi-Fi, hotspot. Okay, so there is a kind of limitless, but you get the idea here. What is media means? It's media means like a connection medium. That's what it's called, media. Okay, and the third one is what is third one? Topology. Okay, so topology is you heard about the topology, right? No, maybe not. Okay, so we have ring. Okay, so ring topology. In old days, the network used to be very non-efficient here. Okay, so this is what net topology looks like. Network topology. So it's a ring topology. So what I'm going to do is I'm not going to spend too much time on this, so I'm going to type ring. This is ring topology. I'm going to paste it in there, and I'm going to super shrink this. You could see, right? This is the reason it's a ring is all the computers are like a ring, sitting in a ring. Okay. Next is bus topology. So why is it bus? Let's take a look here. It's like inline. Okay, so the network is like this silly network. It's an inline. These topologies have evolved throughout the years. Okay, so these some of them are not being used as much. And star. Let's see here. Star topology. Yeah, there you go. So yeah, so the computers and the router is arranged in like a star. That's what is called star topology. And the next one is mesh. Mesh. This is good example. Okay, I'm not talking too much about this because these are self-explanatory. It just looking at the picture itself, you could tell what they look like. Okay, so So the last one is a tree topology. Tree, and I'll just merge this together here. So let's see what is a good example. Okay, yeah, this is a good example. So this is widely used here. Tree topology is widely used and highly managed here. Why? Because we have a backbone here, and each backbone is connected. Um, each backbone has bunch of routers and switches on it, and each router, whenever you add each router, it becomes a subnet. Okay. Whenever you add a router on the network, it becomes a subnet. Okay. Okay. So let me see here. Um, you
Sir, I have a
have,
question. What is a subnet?
yeah, network, and each I just told you, each router you add on the network, each router you add, it becomes a subnet. Subnet means it's a small network in itself. Okay. You add becomes a subnet. Subnetwork, that's what it is. Okay. And each router could handle a maximum of 255 devices. Maximum of 255 devices. Okay, anything which is going to use the IP address is considered a device. Okay, so like a printer, if you have like, if you go out and buy a router, it could support up to 255 devices, and if you want to add more, then you have to get another router. Okay, and actually this is 256. This is 256 devices. Okay, and so how is this getting here? This is 2 to the power of 8. So you're 2 times 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 2, right? How many in there? 1, 2, 3, 4, 5, 6, 7, 8. So if you multiply, somebody's calling me, but if you do 2 times 2 times 2, okay, what am I doing here? If you do 2 times 2 times 2, $16, this is 4, 5, 6, 7, 8. So if you go like 2 to the power of 8, it becomes 256. Okay, we're not worried about why the limit here, but we'll talk about that a little later, because I'm going to explain the IP address a little bit more. Okay, there is a limit is 256. If you go out and buy a router, even your home router should support up to 256 devices. Okay, your home router is capable of 256 devices here. Okay, so how many devices uh, can a home router or OUTER connect? Okay, so it says 250, or it's actually 256, because some of the devices are, some of the number is reserved here. One number is reserved for itself. Okay, one number is reserved for itself here, and there is some reserved numbers. Let's see how many devices you can connect to a router. Most of the wireless access point can support 250 device theoretically connect on a single access point. Okay, so hold on. $250. It's giving the consumer information here. What about 6 more? Okay, how many devices can? Okay, so the reason it's saying 250 is one IP address is saved for itself. Okay, and this is bad information here. Okay, so let's see how many IP addresses. Okay, each router can technically range from 0 to 255. Okay, so why is it saying so 0 to 255 is first is subnet, it specifies IP ranges. The range also determines number of devices that can connect. For most of the time, a range allows 250 connected devices should be sufficient. Pretty much every home. A subnet that allows 255 is the first. And okay, so don't worry about, we're not getting good information online, but this is accurate information. You could get a maximum of 256 devices here, and I'll explain you more, and how many is actually given by the router here. Okay, because router itself keep one IP address for itself, and then based, it has a few more reserved here. Based on that, it will give you that information. Okay, all right, let's move on. Topology is done, and what is the next one is protocol. Okay, protocols, this is kind of big. Protocol. So protocol. What is protocol in simple word? Okay, so in computer world, let's see, in computer world, um, a protocol is a set of rules, right? Protocol is set of rules or procedures for transmitting data between electronic devices, such as computers. Okay, so we'll just keep it that way. So there are several protocols here. Protocols is nothing but rules and regulations. Okay, that's all it is. Don't think more than uh, anything more than what it is. But these are all the different protocols here. Okay, so we'll talk about it. The very first protocol is OSI model. This is a model how the internet, how the communication works on the internet. Okay, so let's see here, OSI protocol. Okay, so this is much more if you take a network class, but this is not a network class, so I just have to show some basic information because this is you need to know this. These are layers here, network layers. This is how pretty much the internet works here, or OSI layer. I don't want to go into details here. Okay. So the layer 1 is physical layer. Okay, this is where the hardware is. Okay, and the layer 2 is data layer. And this is where the data being generated. Okay, the third one is network layer. Okay, so this is a working network. This is where switches, routers, etc. This is where the network layer is. Transport layer. Okay, so what is a transport layer? This is how the it's a communication layer. Communication is being done using several methods. Session layer, the connection, this is the connection established between two hosts. Okay. And then presentation layer. Presentation layer. Okay, data is presented. Okay, to application. And last layer is application. Okay, so what is the application layer here is, for example, if somebody sent you the Word document, it goes through all these layers and it comes to you, and then the application takes it and open it for you. Okay. Example MS Office. Okay, so this is the this is how the basically the network works, or basically the internet works. Okay. Open standard interconnection protocol. Okay, so seven layer model. Okay. Okay, so don't stress too much about this. This is just informational here. You don't have to use it way too much. Okay, so let's work on some protocols here. Uh, there is a protocol called TCP protocol. TCP stands for Transport Control Protocol. Okay, what does it do? It's a connection protocol here. Connection protocol.
Sir, is TCP different from OSI, or is TCP work under the principles of OSI?
It works under the principles of OSI. Very good. I'll tell you, each protocol uses these layers here. So each protocol touches the different layers here. Okay, so give me one moment here. Give me like a minute here. I'll be back. Okay. Yes. Yeah. So we have several protocols here, and they use all these OSI models here. So the TCP protocol uses the data layer, network layer, okay, transport, and application. Okay, so you DNTA. Okay, if you want to remember this, what protocol it.
Sir, your screen is still.
Oh, can you say now?
Yes.
Okay, good. Okay. Who is calling user two? Anybody logged in twice, or is just another person?
Not sure, sir. I'm not. It's not me.
Okay.
It's not me either. I don't know.
Yeah. Okay. All right. So, and it's called connection oriented. oriented protocol. Okay, so let's take a look here. TCP and a TCP protocol has a it makes a three-way connection here. TCP protocol uh, makes a three-way connection, a three-way handshake. That's what it's called. Okay, so let's check on internet what it means. TCP TCP data network transport TCP client and okay, let's do this here. Okay, let's TCP establish connection. Okay, yeah, this one. Okay, so um, okay, so it's called TCP makes a uh, three-way handshake. So what is happening here is when you're making a TCP connection, your client is sending a message that says hello, and then it says it says it sends a replies back hello, and is also replying back yes, I got your first hello, and then it says acknowledgement. So it says sync act. So let's see here. Uh, establishing connection. Okay, so A to B, it says a signal is sent from A to B, so it's called synchronization signal. SY signal is sent. So what B does is B to A. So this is A and this is B. Okay. B to A. It says it also gives its own synchronization signal and a reply, which is an acknowledgement. So it is giving you it's sending in the signal in its own signal, and it is acknowledging the signal that it has received this first signal from A, and then A to B, it says it gets the acknowledgement. Okay. Then once the connection is deployed, connection established, and data is transferred. Okay. So in short, what do you say? You say sync act, sync act. Okay, so just leave it right there. Okay, so this is the handshake connection is established. Okay, and then there is a connection termination too. Okay, so TCP connection termination. Termination. So let's see here. This is I want to say closing connection right here. Yeah, this is good. So this is called closing connection. Okay, it's taking so long for me to grab this. All this is happening in a fraction of a second, okay? And it doesn't take even long if you're making a connection halfway across the world. All this is happening in a fraction of a second. A to B is A to B sends a signal that says I'm finished. Okay, so it says complete connection. And B to A, it says acknowledge to finish connection. Okay, and then A to B, it says is acknowledge the receipt of final signal. Okay, so what is happening here is A says okay, I'm finished, and then B says is acknowledge and also sends a B to A send. B to A acknowledges the finish connection and uh, sends the finish connection, and then A to B sends is acknowledge the final signal here. Okay, so in short, this is fin fin act act. Fin act, and the connection establishes sync act. Okay, so somebody in the interview might ask you, how is the connection established, or how is the TCP connection terminated? All you have to do is sync act if to establish a connection, and to complete a connection, finac act. Okay. All right. So I'll stop it here, and I'll pick it up Saturday again. Okay. As soon as I'm done here, I'll upload these videos here.